about endothermic and exothermic reaction, and then something called enthalpy. Thermodynamics is the relationship between chemical reaction and heat. So when a chemical reaction happens, there is a change in heat, meaning a movement of energy either out or into the system. Now, what causes chemical change to occur? It is the bonding and breaking of bonds. Okay, so reactions happen when bonds are broken and new bonds are formed. And when bonds are broken, energy is released, and when bonds are formed, energy is absorbed. And there is a difference in the amount of energy that is used right there. So if there's excess energy, then it is released in the form of heat. If it is less than needed energy, then you will have to add energy, thus in the form of an endothermic reaction. Okay. Later on, you will learn the concepts. But in there, you're going to learn the concept of enthalpy, entropy, and free energy. We might not get all to them, but we'll try as much as possible. Now, before we talk about that, we have to talk about two things. Let's talk about the system and the surrounding. Now, the system is the actual chemical reaction that is taking place. Okay, so that's like the molecules that are happening. The surrounding is everything around it. Okay, so surrounding is anything around that system. Okay, so like say for example, if sodium's reacting to chlorine, the sodium and chlorine would be the system. The surrounding would be where they are doing the reaction, like in water. So here is an example of an endothermic process. Now we heard this before. An endothermic process is where energy is actually absorbed into the system to create a reaction that happens. So anything that absorbs energy, it is endothermic. When you touch it, it's kind of cold because what it's doing is basically absorbing the heat, and the heat is basically going out of your body, go out of where you're touching, so it causes your feeling to be cold. An exothermic system means it has excess heat, which means it's going to give off that heat. Excess energy is going to give off that heat in the form of heat, and the temperature around it is going to be raised. Now, enthalpy is the change of that energy. Okay, so the enthalpy is the heat of the product minus the heat of the reactants. Remember the activation energy curve that we talked about? So delta H is equal to the heat of the product minus the heat of the reactants. So now, if you look at this, burning hydrogen fuel right here have a delta H of negative 572 kilojoules, which means when hydrogen reacts with oxygen to make water, we actually give up 572 kilojoules of energy. Now remember, kilojoules is just a unit of heat measurement. But if we take the same process and we go backwards, and we take water and we split into hydrogen and oxygen, it actually absorbs 572 kilojoules. So it takes more energy to split this than energy to make them. Whoops. Now, have you noticed the difference? Okay, so an endothermic process, an exothermic process of the same process, you notice that energy goes in and out. It's the same amount of energy. Okay. Now, heat versus temperature. You know, in our life, we use heat and temperature interchangeably, but heat and temperature is very different. Heat is a form of energy measured in joules, and it's also the movement of energy. Okay. Temperature is the average kinetic energy of the molecules or of the system or the whole thing. Okay, and it's measured in Kelvin. So the two things is very different. Okay, there's something that can have a lot of heat, but the same amount of energy, the amount of temperature, as something that has very little heat. Okay, so let's take a look at enthalpy and stoichiometry. We can use stoichiometry to do enthalpy problems. Okay, so for example, in this reaction, we have 2 moles of high peroxide, H2O2. It's going to break down into oxygen plus 2 moles of water. Now, the enthalpy of that is negative 186 kilojoules, which means this process is exothermic. Now, this is negative 186 kilojoules per mole of the H2O2. So 2 moles of H2O2 will produce this much energy. Okay, so how much heat is released when 3.56 grams of H2O2 peroxide decomposes into water and oxygen gas? So we want to know, if we have this much peroxide, how much energy we're going to produce. So the first thing we'll do is we're going to take this 3.56 grams of peroxide and we're going to change that into moles of peroxide. Now remember that 1 mole of peroxide is equal to 34.02 grams of peroxide, H2O2. We did that by finding the oxygen, which is 16 times 2 plus 2 of the hydrogen makes it 34. When we finish that, notice that the grams of hydrogen will cancel out and we give you mole. Now based on the equation above, we know that there are 2 moles of H2O2 to produce this much of the heat. So we now negative 186 kilojoules of energy produces 2 moles of or is used in produce in destroying 2 moles of peroxide. So again, notice that moles of peroxide is going to cancel out, leaving us with negative 9.73 kilojoules. So 3.56 gram of peroxide will produce 9.73 kilojoules. So here's another example. In this case, propane plus oxygen, propane is found in your barbecue, okay, plus oxygen makes 3 moles of carbon dioxide and 4 moles of water. The delta H is negative 2,219 kilojoules. That's a lot of energy, okay? So what happened if I want to produce 8,493 kilojoules of heat? Now remember, I can use the stoichiometric relationship that 2,219 kilojoules is going to be produced for every 1 mole of the methane. I mean, it's not methane, I'm sorry, the propane, okay? So what I'm going to do is I'm going to take the amount given to me, okay, and I know this is an exothermic reaction, so that's negative 849.32 joules. I know that 1 mole of methane, not methane, I keep saying methane, propane, will produce 2,219, so there it is, 1 mole of propane over 2019. Again, I put kilojoules on the bottom so the joules can cancel out. Okay, that gives me moles. And of course, for moles, I can change it to gram by knowing what the molar mass of the propane is. So I know that it is 168.3 grams of the propane was created. So go over this again, and then tomorrow we'll be working with this in class.